In this video, we will discuss the tutorial questions on sampling distribution. Because there's a special request, I'm going to start with question number 6 first. As usual, in any statistical question, it's best that we extract the information provided. And to do so, I will highlight the important information that I see. We have 300 UTEM students. This will be the sample size. 30% of the mean scores were below 65, crucial information, and also 15% were above 90. Find the mean and standard deviation, assuming that the scores are normally distributed. Our duty is to find the mu and sigma, and the information provided is n is equals to 300. I would also like to illustrate the information provided here, which is that 30% of the mean scores were above 65 marks. So above 65 marks were 30% of the mean scores. And 15% were above 90. So 15% of the marks were above 90. Okay, so find the mean and standard deviation. Now, after illustrating the question, I would translate this into our statistical form. So we have the probability that the mean scores were below 65 is 30%, and the probability that the mean scores were above 90. Now, because we are supposed to find the values of mean and standard deviation, I am pretty sure you need to check up your statistical table. And so when you do check your statistical table, it always gives you the probability that Z is less than a value. So I would change greater than to less than. So less than 90 marks would be 0.85. Less than 90 marks is 0.85. The next step is to conduct the transformation to your normal distribution. So the formula is x bar minus mu over sigma over square root of n. X bar minus mu over sigma over square root of n. Next, we need to check the Z value when the probability is 0.85 and the Z value for the probability 0.3. So when the probability is 0.85, the Z value is 1.04. When the probability is 0.3, the Z value is negative 0.52. This is 1.04, the Z value, 90 minus mu. And this one was negative 0.52, the Z value. I'm pretty sure by now everyone knows that to find the values of mean and standard deviation, we need to solve for the simultaneous equation. So I'll try to make this equation simpler. I have here 65 minus mu equals to negative 0.52 times sigma over square root of 300. This will be my first equation. And from here, I have 90 minus mu equals to 1.04 sigma over square root of 300. This is 300. This will be the second equation. Okay, so if I take the second equation minus with the first equation, I would get 90 minus 65 as 25 equals to mu, negative mu plus mu is 0. 1.04 sigma over square root of 300 plus 0.52 sigma over square root of 300. And you would get 25 equals to 1.56 sigma over square root of 300, which gives you sigma as 277.5722. I would then substitute this into 1 and I would get the mean as 73.3333. Okay, in this question you are given the average as 7, standard deviation 1. Find the probability of a random sample of 9. Sigma is 1, mu is 7. So for question A, n equals to 9. Find the probability that the mean life falls between 6.4 and 7.5. This is quite easy then. You simply standardize using the formula we've discussed before. 7.5 minus mu over sigma with square root of n. And this is quite easy to solve, so I'll leave it to you to solve. Now question B. N is again 9. Find the probability that the mean life is more than the population. Okay, I would illustrate. The mean is 7. Mean life is more than the population mean by at least 2 standard deviations. So the standard deviation is 1. 2 times 1 is 2. This would be 2. 7 plus 2 is 9. More, then this would be the area that we are interested in. So you want to find the probability that the mean life is greater than 9. Okay, I'll leave it to you to solve this. The next step is to transform and then use your calculator to find the probability. Okay, question C. I would again illustrate the value of x bar to the right. So to the right is towards your right hand side, of which 15%, this is 15% of the means computed would fall. Okay, let's say I'm going to name this as A. So you want to find the probability that the x bar greater than A is equals to 0.15. And because you would need to find the Z value using a statistical table, I would suggest you to change this to less than A equals to 0.85 and to solve it. So next you would transform and try to solve it yourself. So in this question you are given the average as Y, standard deviation is 1.4, random sample 49. Mu Y, sigma 1.4 and 49. What's the value of Y so that there is a 99% chance that the sample mean will be at least? Okay, this is quite easy. Illustrate, always illustrate. 99%, okay, the clue is from the word at least. So the minimum value is 13.634 and the probability here would be 0.99. So you're supposed to find this x bar. Now, you're given the probability, so definitely you need to use your statistical table. I would change greater to less than 13.634 equals to 0.01, this area. And then I would transform and then solve it. 13.634 minus mu is y over sigma over square root of 49 equals to 0.01. And the next step is to be checking your statistical table for the z value when the probability is 0.01. I'll leave you to do that yourself. I trust that you could solve it easily. And the next question, once you have the value of y, then you can find the probability that the sample mean will be below is less than 13.5 or above, means greater than 14.8 minutes. So in this case, x bar less than 13.5 plus the probability of x bar greater than 14.8. On to the next question. Okay, average is this, standard deviation is this, sample size is this. What's the probability that the sample mean will be at least? What is at least? X bar greater or equals to 4.57. That's quite easy. It's question B. There's an 85% chance that the sample average will fall between two values symmetrically. The word symmetrically, two values. So this will be 85%, 0.85, and you need to find these two values. Let's say this is value B and C. What I would do is, I would rewrite this into the probability that x bar less than B, how much is it? This will be 1 minus 0.85 divided by 2, which is 0.075. And then you would standardize and try to solve it using your statistical table. And next, x bar greater than C is 0.075 as well. But because you will be needing to use your statistical table, I would change this to x bar less than C is 1 minus this, which is 0.925. And then you would also solve this using your statistical table. What's important in this question is the 77%, and we have the sample size of 120. So find the probability that the value of p hat, the mean will be your p, and your p is 0.77. So not within is plus and minus. So plus 0.15 and minus 0.15. Within is here, this area here. So not within will be the area on your right hand side and the area on your left hand side. Now we need to find these two values here. So this value will be 0.77 minus 0.15, which is 0.62. And this value will be 0.77 plus 0.15, which is 0.92. So I would do this probability of p hat less than 0.62 plus the probability of p hat greater than 0.92. Then I would standardize. What's the formula? 0.62 p hat minus p, 0.77 divided by square root of p times q. So p is 0.77, q is 1 minus p. So 1 minus 0.77 is 0.8. 0.23 divided by n 120 plus z greater than 0.92 minus 0.77 divided by 0.77 times 0.23 divided by 120. So this can easily be solved using your calculator. The R function and the P function. Okay, question number 9. A company that manufactures soda claims that 85% of their soda drinks are good for 4 years or longer. Assume the claim is true. P hat is the proportion, random sample, 100 soda drinks that are good for 4 years or longer. So this is a success, right? 4 years or longer is the success. Question A. What's the probability that the sample proportion is within 0.05 of the population proportion? Everyone knows that the population proportion is 0.85. So within would be plus and minus 0.05. 0.85 plus 0.05, you get 0.9, and 0.85 minus 0.05, 0.8. So for question A, you would find this area here, which is the probability that P hat is between 0.8 and 0.9. On to question B. What's the probability that the sample proportion is less than population proportion? So the population proportion is 0.85, less than by how much? 0.06. Less than by 0.06, this would be 0.79. Okay, less than by 0.06 or more. So you will find the probability that P hat is less than 0.79. Question C. This is the opposite of that. So your population proportion is still 0.85, more than the population proportion by 0.07 or more, this area. And this is 0.92. I'm going to find the property that P hat is greater than 0.92. What's important in this question is this 85% proportion of females in an organization and the random sample of 500 individuals. So question A, what are the mean and standard deviation of P hat? Mean of P hat would be simply P, which is 0.85, the proportion of females in the organization. The standard deviation of P hat is square root of PQ over N, and P is 0.85. Q would be 1 minus P, 0.15, divided by N, 500. The answer would be 0.016. For question B, is the distribution of P hat approximately normal? Justify your answer. So when would the distribution of P hat be approximately normal? When the sample size is large. And when is the sample size large for proportions? It's when NP and NQ is greater than 5. So we need to check on these things. So NP will be 500 times 0.85. This gives us 425, which is greater than 5. And NQ is 500 times 0.15, gives us a total of 75, and this is definitely greater than 5. So the distribution of P hat is approximately normal because NP and NQ is greater than 5. Question C. What's the probability that the sample proportion exceeds 82. This is quite easy. The probability that P hat exceeds 0.82. So then you would transform to Z and find the probability using your calculator, using the R function in your calculator. In question D, what's the probability that the sample proportion lies between 83% and 88%? This is also quite easy. So P hat between 0.83 and 0.88. Right, now question E. 99% of the time, the sample proportion would lie between what two symmetrical limits? We've discussed this before, and here would be 0.99. You need to find the values of B and C here. So what's the probability of this area? 1 minus 0.99 divided by 2, which is 0.005, similar to the one here. So how I would solve this is by taking the probability of P hat less than B is equals to 0.005, and then I would be transforming this and find B from the statistical table. To find the value of C, instead of looking at this area here, I would be looking at this whole area here, because we'll be needing the statistical table to solve the problem. So P hat less than C is equals to 1 minus 0.05. Then I would transform and solve the problem. In this question, it's given that 55% of the voters favor the construction of the building. Assume that the result holds true for the population. Okay, so what's the probability that more than 50% of the voters in a random sample of 150 voters selected will favor the construction? So the success in this question is those who are in favor of the construction. So question A, P would be 0.55, N is 150. I'm going to find the probability that P hat is greater than 0.5. It's quite easy. In question B, a politician would like to take a random sample of voters in which over 50 would favor the, okay, so this is the success again, those who are in favor. How large a sample? That means we need to find N. How large a sample should be selected so that the politician is 95.5% sure of the outcome? Okay, over 50%, and the probability is 95.5%. Over would be towards my right hand side. So this area is 0.955. And this would be 50% on 0.5. So let's transform the illustration to your statistical formula. P hat greater than 0.5 equals to 0.955. Definitely we need to use the table to solve for N. So I'm going to change this to less than 0.5 equals to 1 minus 0.955 is 0.045. So this gives me Z is less than 0.5 minus P over square root of PQ. Q is 1 minus 0.55, 0.45 divided by N equals to 0.045. And then I would check from the table, the probability is given as this. I would check for the Z value and solve for N. Now, when you solve for n, you might get a decimal value such as 25.04. Okay. For your sample size, you always need it to be in an integer. So in this case, we need to round up 25.04 to 26, as we've previously discussed in class. In this question, the P is provided as 88%. Students who passed all subjects and completed the studies in 4 years. Then a random sample of 132 was selected. Find the probability that the sample proportion is within 0.1 of the population mean. Okay, so we have P as 0.88 and N is 132. We need to find the probability that the sample proportion is within 0.1. I would illustrate this. And this is the population proportion 0.88 within 0.1 plus and minus 0.1. So these two values would be 0.98 and 0.78. In order to solve this question, we simply find the probability that P hat is between 0.78 and 0.98. Okay, next, find the number of samples. So you need to find N. If the probability is 0.38, that at most 81% of UTM students pass all subjects and completed the studies in 4 years' time. So again, this is the success. Probability is 0.38 and at most 81%. So what is at most? At most would be the maximum value. Probability is 0.38. This value here is 0.81. So in order to solve this question, to find the value of N, I would rewrite the question as P hat less than 0.81 is equals to 0.38. And then I would transform to 0.81 minus 0.88 divided by square root of 0.88 times 1 minus 0.88 is 0.12 over n. This is 0.38. You could find n simply by checking out the probability in your statistical table and looking for the z value. And remember, once you get the value of n, if it's in a decimal, you need to change it to an integer. How do you change it to an integer? You need to round up. Okay class, thank you so much for your attention. I'll see you in the next video.